I'm Sergey Kolpinsky, and I'm a researcher for Infotex, and I study phishing domain names and type squatting using the strings. So, if we would like to find domain names that look similar to popular resources, the ones that are not noticeable by the user, well, you know it. Usage of such domains is called type squatting for typos, and here are three domain names: PHDays, Infotex, and Kososlogin. All the options are available for purchase. Let me describe how those domain names are created. The type squatting techniques from literature are, adding symbols in random places, repeating the symbols, adding some leading characters, changing one bit, replacing two neighboring symbols on the keyboard, replacing the symbols to the ones that look very similar, replacing the vowels, omission of symbols, and putting them in different places. So what's the idea? First of all, you need to create the list of protected domains. Then, by using the type squatting methods, you might need to generate those phishing domains, decide how you compare them, and find domains that are close to the ones that you are trying to protect. So let's use this as a plan. First of all, if we create a list of domains to protect, what should we focus on? We should not focus on everything on the internet, but probably on some important sites, right? So whether it's top sites, popular sites, banking sites, government services, corporate domains, the sources might be different companies from top lists, Majestics, Alexa, etc., or the usage statistics. After you define the list of those, you can generate using a utility. GitHub has it, DNS Twist. It's an open source utility that allows for a given domain name to generate a lot of similar permutations of domain. It can also ping them by DNS and find similar domains. It works as a command line utility, as a Python module, as a web page. You can put your site there and scan. And a spoiler is that there will be a lot of them. Next, we now need to understand how we can compare the domains. We can measure the distance between the symbols, and we might define it as an inverted space between the symbols. There are different ways, but the Tamara-Levenstein one is interesting. It's the measure of difference between two strings that is defined by the amount of operations of removal, replacement, and transposition of the two nearby symbols that are needed to transform one string into another. So it's very similar to what the type squatting people do, right? When you have everything defined, you just need to develop a technique to find those phishing domains and find the distance between the target domain and the protected domains. So we calculate the distance and find the minimal one. We had a hypothesis that for phishing domains, this measure will be small, and for non-phishing, it will be high. And this is how they can be delimited. So we need to prepare the steps, create the list of the protected domains, generate permutations, calculate the number, the distance, and based on that array to find the values and the thresholds. Here you just need to calculate the distance, and the two rules are: if it's 0, then it's one of the protected domains. If it's not equal to 0, then we need to decide whether it's more or less than the threshold. If it's more than a threshold, then it's some other domain that we don't consider a domain that's being protected. And our sweet spot where we do our protection is when the distance is more than 0 but less than some threshold. So we gathered some data, Alexa top 500 sites, for example. This is the number of objects. We've created 1.5 million pseudo-phishing domains. 1.2 went to threshold calculation and 300K for testing. And also I added 300,000 others from Alexa top million. So we calculate the distance for that 1.2 million blue ones. We define the threshold, the max. The red line is too high. And the balanced ones are 99 percentile, the violet, and the green one is the box plot top. And let's add our test domains here. My phishing domains, and the distributions are very discrete. And the threshold is too high, then recall is 1 and precision is low, and two others are more balanced. So the accuracy for max is 0.6. I have a 1.0 recall, but the precision is 0.5. But if I reduce it, if I allow myself to lose 1% of them, then the precision and accuracy are much higher. The idea of my presentation was that this method allows for finding domain names that are type squatting, and we can work ahead to actually decide which domains might be dangerous. And this method allows us to say whether this domain name is a phishing one or not. And besides asking for minimum, we can also define the one that they are squatting. So like Sberbank Online would look very much like Sberbank's site, right? So finding, purchasing, and redirecting people to a legitimate domain might be a good idea. Registrars might look for such domains also and propose their purchase to the legal owners. Also corporate emails addresses, not the best way, but one of the good rules to actually base your rules on. Thanks for the presentation. And the question is, what do you do with the sites that are aimed at an external user? See, we've created an oil company site and we're selling oil. That was something that really happened. What do I do in that case? So imagine we have an oil company and the actors have created a domain with a very similar name that they used to sell oil. Sure, yeah. You need to work with the authorities to stop this. So my technique was just comparing the strings. Yeah, sorry, I don't have the full solution for you. We, of course, have all the contacts and social networks, so feel free to subscribe. How do you run the validation? So we got those phishing domains, and we know what is there. And I had an experience working with DNS and automating that process. So you get 200 or 300 of those sites, checking for content or something else. This is one of the features that you can use for further checks, but it's not the final solution. You can use the content. You can. I don't have enough time to explain all the potential applications.